Today we're going to talk about how to convert between radical form and exponential form. So the main format is, this is radical format. You can see the radical, and this works for any root. N is going to be our root, and n is going to be the exponent. When we convert to exponential form, notice whatever the exponent is going to go to the top of the fraction, and whatever the root is going to go to the denominator. Some students told me they remember it by saying the root goes on the bottom because roots are on the bottom. Or other students told me, well, the bottom goes in the crack because your bottom has a crack. You can use whatever method you want to help you remember it. So let's practice a couple examples. So notice this is the fourth root, which means it's going to go in the denominator, and the exponent is going to go in the numerator. So that's how you would convert from radical form to exponential form. Notice I can't reduce 3 over 4, so I just stop there. All right, let's look at this example over here. This time I'm in exponential form, and I want to convert it into radical form. So I'm going to take, the 3 is the root. I'm going to do the cube root of negative 125x. Since 1 is my exponent, I don't really need to write it because anything to the first power is just that number. So now let's see if we can simplify it. Well, the cube root of negative 125 is negative 5. You can always type this in your calculator if you're not sure. Under math, there is a cube root button. You also could type negative 25 to the 1/3 power in your calculator, and you'll see that you'll get negative 5. Now we can't reduce the x, so we are going to leave it inside of the cube root. So those are some very basic conversions between radical form and exponential form. Now let's try a little bit more complex ones. All right, now we're going to review some laws of exponents. So the first law that we want to remember is what to do with our exponents when we're multiplying. So when you're multiplying, we add our exponents. So I'm going to keep the base the same of 12, and then I'm going to add my exponents. So 1/2 plus 3/2 is 4/2. Remember, when we're adding fractions, the denominator has to be the same, which we keep, and we add the numerators. Now I can reduce 4 over 2. I know that 4 divided by 2 is just 2. And 12 squared, of course, is 144. So that's how I would reduce that down. Our next law is very similar to this one when we're dividing. Remember that we added exponents when we were multiplying. So when we're dividing, we subtract exponents. So my base is going to stay the same, 125. 2/3 minus 1/3 is 1/3. I can simplify this one step farther. Because I know that I can change this into radical form that we just did, this is the same as asking what is the cube root of 125, which is 5. All right, one more law of exponent that we need to know is power to a power. When I have an exponent raised to another power, the rule is that we multiply our exponents. So I'm going to multiply straight across. I'm going to write this a little bit better so you can see it. Keep in mind, this does not have a denominator, so we know a 1 is implied. So 2 times 3 is 6. 3 times 1 is 3. So I multiplied straight across those two exponents. 6 over 3 reduces to 8 squared, and 8 squared is 64. All right, the last rule that I want to remind you about for the laws of exponents is that you need to be sure and distribute powers to everything in the parentheses if it's being multiplied together in the parentheses. So we have 16 times 25 to the 1/2 power. This is the same as saying 16 to the 1/2 power times 25 to the 1/2 power. Remember, raising something to the power of the 1/2 is the same as saying take the square root of that number. So this is the same as saying take the square root of 16 times the square root of 25. Square root of 16 is 4, Square root of 25 is 5. Therefore, we can simplify this down to be 20. So these are some basic laws of exponents that are really going to come in handy for these problems we're about to do. All right, let's work a couple last examples together to practice this. Now, example 1, notice we have 2 sets of parentheses. Whenever we have multiple parentheses, we always want to work at the very most inner and then work our way out. So for the time being, I'm going to ignore the 3/2 and just work this inner part first. So first, I'm going to do 16 to the 1/2 power, which is the same as asking what's the square root of 16. That's 4. So that part is 4. Then I have power to a power. If you remember that rule, when we have power raised to a power, we multiply our exponents. So 12 times 1/2 is x to the 6th power. Now, I'm going to take care of the second set of parentheses, which is raising it to the 3/2 power. So watch carefully when I do this. Remember, the root is in the denominator. So this is saying take the square root of 4. The square root of 4 is 2. 2 to the 3rd power is 8. I'm going to say that one more time. First, the denominator means take the square root of 4. The square root of 4 is 2. 2 to the 3rd power, meaning 2 times 2 times 2 is 8. So that's how I got that. If you get stuck, you can type it into your calculator to check yourself. You would type 4 to the 3/2 power in your calculator, and you should get 8. All right, now let's deal with the x. Remember, power to a power, again, I'm multiplying my exponents. So there is a 1 to be implied underneath the 6. So I've got 6 times 3, 18, and then 2 times 1 is 2. So 18 divided by 2 is 9. So this would simplify down to be 8x to the 9th. All right, in example 2, we are raising it to the 1/2 power, which is the same as saying take the square root of what's inside of the parentheses. So the square root of 1 is 1. The square root of 16 is 4. Now I have power raised to a power. So when it's power raised to a power, again, I multiply my exponents. So 9 times 1 over 2. Now this one doesn't go evenly, so it's a little bit different. There's 2 possible correct answers here. One is if it asks for exponential form, this would be your answer, because that is the reduced exponential form. However, if your teacher asks you to write reduced radical form, then we need to reduce this fraction right here. And here's how you do it. We know that this is a square root, so I'm going to write my square root. My 1/4 is going to be out front because it's already reduced. We have already done the square root of 1/16 to get 1/4. So we ask ourselves, how many times does 2 go into 9? It goes in 4 times. So that's x to the 4th. And when we do that, that goes in 8. So there's 1x left over. Let me explain it in a little bit different way. Think about when we had this radical right here. Okay? If I rewrote this, it's the square root, remember square is implied, of x to the 9th. If I rewrote that in radical form. Okay? I can break this down up to x to the 4th times x. Well, I'm going to do 8. X to the 8th. Because if I have 8 over 2, that is the 4, and then the 1x is left inside the house. These take a little bit practice, but these are 2 different ways of kind of thinking of the same concept. You would end up in the same way. So this would be called reduced radical form. All right, let's practice that again. So this time, notice there is no root written. So the square root is always implied. This is still just a square root. If there's a number there, we know that it is a different kind of root. So this is our square root, we know that a 2 is implied there. Now, the square root of 12 will give us a long decimal if we type it into our calculator, and we do not want a decimal answer when we're reducing radicals. We want to try to see if there is a perfect square, because we're doing a square root, that will divide into 12. Well, if you think about our perfect squares of 2 squared is 4, 3 squared is 9, 4 squared is 16. If we start thinking of these perfect squares, we know that 4 will go into 12. 4 goes into 12 3 times. This is helpful because I can take the square root of 4. That is 2. But since the 3 is not perfect, I have to leave it inside the radical. All right, let's deal with the x. X squared, and then my root is 2. Would put that in the denominator. When I reduce this, 2 over 2 is just x. And I don't have any leftover x's, meaning there will be nothing left inside the radical. It's a perfect square. Let's look at the y's. If I rewrite this, it's 5 over 2. So we ask the question, how many times does 2 go into 5? It goes 2 times, so a y squared can come out with 1 y left over. So that's how we can reduce that down. 1 y has to stay in because 2 goes into 5 2 times, which gives us 4, and then there's 1 y left over. So this would be our final reduced form. All right, we have one last example left. This time we're taking the cube root. The cube root of 64, that's a perfect cube. It's 4. I'm going to go ahead and draw my cube root in case I have any leftovers. All right, I have x. If I rewrite this, it'll be 6 over 3. Well, 6 over 3 reduces to x squared. It's a perfect square, or perfect cube, I should say. And y can be rewritten as 5 over 3 as the exponent. All right, here we're going to try reducing it again. 3 goes into 5 1 time, which means 1 y can come out. And there are 2 y's left over, so we leave y squared in the house. So you notice whatever's the leftovers always stay inside the house. Whatever goes in evenly, however many times it goes in evenly, is what is going to come outside of your radical. So that's the basics of simplifying radicals. These take a lot of practice, so make sure and do all of your homework problems so that you really can get the hang of it.